Assalamualaikum everyone and good evening. My name is Nur Kitina Batisha and my matrix number is F1030.
My name is Nur Shafia Wahida binti Nur Safaruddin and my matrix number is F1022.
My name is Putri Nur Ain Humaira binti Sharudin and my matrix number is F1018.
I'm Kartini and my matrix number is F1003.
Okay, so today our group will be present about
Common issues in Malaysia that related to soil.
Soil mechanics plays an important role in ensuring the stability and safety of engineering structures. Problems such as weak soil, poor drainage, and slope stability can lead to ground failure, including settlement and landslide. This presentation discusses a case related to soil failure by covering the location, soil types, problems, and identified causes. It is also explains the factors contributing to severe soil settlement and its impact. Finally, suitable improvement methods based on Malaysian standards are proposed to enhance safety and long-term performance. Okay, so now I will explain detail about the case that we have chosen, which is the Highland Tower tragedy. Okay, about the case, this incident occurred on 11 December 1983. At Taman Hillview, Ulu Kelang, Selangor. The Highland Towers consist of 12-story apartment blocks built between 1975 and 1978. Okay, so what happened? After 10 days of continuous heavy rainfall, Block 1 suddenly collapsed at around 1:30 p.m. The collapse was caused by a major landslide which buried many residents under the debris. As a result, 48 people lost their life and only 3 survivors were found within the first 24 hours. This tragedy became one of the most significant landslide disasters in Malaysia. On this slide provides an overview of the Highland Towers tragedy, which is one of the most significant landslide-related disasters in Malaysia. Starting with the location and year. Highland Towers is situated in Ulu Kelang, Selangor. The incidents occurred on 11 December 1993, when one block of the apartment suddenly collapsed due to slope failure. Next, look at the soil type in the area. The site is mainly composed of soft clay soil, which is commonly found in hilly regions. This type of soil has a high ability to retain water, especially during heavy rainfall. When the soil becomes saturated, its shear strength decreases, making it weaker and unable to support loads effectively. So, this condition leads to low stability, increasing the risk of landslide. Now, moving on to the problems identified. Okay, the primary issue was the slope failure or landslide that occurred behind the building. This was mainly caused by excess water accumulation and poor drainage, which increased the poor water pressure in the soil. So, as a result, the soil mass began to move downhill. This movement caused a loss of structural support at the building foundation. Without proper support, the structure could no longer remain stable, leading to collapse of Block 1. Before the collapse, there were also warning signs such as cracks in the ground and surrounding structures, which indicate to soil instability and differentiation movement. However, these signs were not effectively addressed in time. In conclusion, the disaster was mainly due to the combination of weak soil condition, high moisture content, poor drainage system, and slope instability, which is ultimately led to tragic collapse.
Now I will explain the main issues that led to the Highland Towers tragedy. First, we have the landslide trigger. The slope became unstable, causing a mass of soil to move downhill. This indicates that the slope had reached its limit equilibrium, meaning the soil could no longer resist the forces acting on it. As a result, failure occurred and the landslide was initiated. Next is structural collapse. Due to the ground movement caused by the landslide, the foundation of the building was compromised. When the soil beneath the structure became unstable, it could no longer support the load of the building. This led directly to the collapse of the structure. Moving on to the settlement. Before and during the failure, there were signs of ground deformation. This includes differential settlement, where parts of the ground sink unevenly. Water infiltration also weakened the soil layers, causing them to shift and further reduce stability. Finally, we have debris flow impact. After the landslide, soil, water, and debris flowed into the residential area. This caused severe destruction to nearby structures and significantly increased the hazard to the surrounding buildings and residents. In conclusion, these issues are all interconnected, starting from the slope instability leading to foundation failure and unlimitedly resulting the catastrophic structural collapse.
The slope failure at Highland Tower can be explained to several interacting geotechnical factors. Firstly, prolonged heavy rainfall causes the soil to become more fully saturated, which is increase the pore pressure and reduce the effectiveness stress. As a result, the shear strength of the soil decreased significantly, making the slope more vulnerable to the failure. The situation was further aggravated by the failure of deposition pipes. Instead of safely channeling water away, the pipes burst and allow uncontrolled phase runoff, carrying debris and silt into the slope, which is increasing the load on the soil mass. At the same time, inadequate drainage system prevent proper dissipation of the excessive water within the ground. This led to the continuous build-up of pore water pressure, further weakening the soil structure. Consequently, the foundation system was unable to withstand the increases lateral earth pressure exerted by the unstable soil. Overall, the combination of elevated pore water pressure, reduced shear strength, and sufficient structural resistance led to the slope failure.
Based on the analysis, the collapse happened due to drainage failure, unstable slope condition, and weak foundation support. Poor water drainage increased pressure behind the retaining wall, while hillside development added extra soil load. This factor caused soil movement weakened in the building foundation, which finally resulted in structural collapse.
Now I will explain the recommended improvement to prevent incidents like the Highland Towers tragedy. This method focuses on increasing soil stability and reducing the risk of slope failure. For the first method, we have soil stabilization. This method involves improving the engineering properties of the soil, such as its strength and stiffness. By stabilizing the soil, we can reduce its compressibility and making it more resistant to external loads and the environmental factors. As a result, the slope becomes more stable and less likely to fail, even under heavy rainfalls or additional loading. This directly addresses the root causes of the landslide, which is weak and unstable soil. The second method is implementing a proper drainage system. Water plays a major role in slope failure because it increases pore water pressure within the soil. By installing an effective drainage system, we can prevent water accumulation and allow excess water to flow away safely. This helps maintain the soil shear strength and significantly improves the slope stability. In other words, controlling water reduces the risk of landslides and protects the structure from foundation failure.
For this improvement, we propose using retaining structures. Retaining walls or reinforced earth systems are built to support the slope and prevent soil movement. This method works by resisting the pressure from the soil, which helps to reduce the risk of landslides. It is especially effective in areas with weak or unstable soil condition. So in conclusion, retaining structure provide a safe and long-term solution for slope stability. For the long-term effects, this tragedy caused major economic losses due to compensation, legal settlement, redevelopment, and maintenance costs. In terms of safety, the collapse led to stricter hill slope development control, better drainage system, and stronger building system regulation in Malaysia.
So, in conclusion, the Highland Towers tragedy shows how multiple engineering failures can lead to a catastrophic disaster. The combination of weak soil, poor drainage, and inadequate design caused slope failures and ultimately the building collapse. This incident highlights the importance of proper site investigation, effective drainage system, and safe engineering design. The last but not least, it also emphasized the need for strict monitoring and maintenance to ensure long-term safety and prevent similar tragedies in the future. That is all from us. Thank you.